So I propose that we start the session. It's my pleasure to welcome all of you to this fifth session of the Digital Fast Track Studios, which are co-organized by the Graduate Institute of International and Development Studies at Geneva, the Geneva Liaison Office of UNESCO, and Microsoft. 2 weeks ago, June 8th, was the World Ocean Day, the United Nations Day for celebrating the role of the oceans in our life and inspiring action to protect the ocean and sustainably use marine resources. And it seemed to us that this was a good opportunity to reflect on the role of data and digital technologies in the protection of our environment. Making peace with nature is one of the 10 priorities for 2021 that UN Secretary General Antonio Guterres outlined to the General Assembly in January of this year. In order to make peace with nature, we first need to learn about nature. We need to measure and monitor its constituent elements, soil, water, air, plants, and animals. And there are literally trillions of data points that we can capture and analyze to learn about and to make peace with nature. Digital technologies can help in this process, ranging from data centers running on renewable energy, hopefully, to host those massive data sets, to machine learning technologies to process them and discover patterns, for instance, in carbon production or biodiversity loss, to satellite imaging and 3D printing to help recover and then reuse plastic waste. Today, we have the privilege to welcome 3 renowned experts to discuss how data and digital technologies can help make peace with nature. Levin is a distinguished professor of biological oceanography and marine ecology at the Scripps Institution of Oceanography at San Diego, California. She's focusing on deep ocean environments, and among her many achievements, please allow me to highlight her founding role in the Deep Ocean Stewardships Initiative, a global network of experts which seeks to integrate science, technology, policy, law, and economics to advise on ecosystem-based management of resource use in the deep ocean, as well as strategies to maintain the integrity of deep ocean ecosystems. Dr. Levin was the 2019 recipient of the Prince Albert I Grand Medal for Science for her work. Bill Adams is a visiting professor and holder of the Claudio Segré Chair of Conservation and Development at the Graduate Institute Center for International Environmental Studies at Geneva. And prior to joining the Graduate Institute in 2020, Professor Adams held the Moran Chair in Conservation and Development in the Department of Geography at the University of Cambridge. Professor Adams' research explores relations between society and nature from the perspective of political ecology and environmental history. His current research focuses on the ways in which novel technologies shape ideas about nature and its conservation. Lucas Joppa is Microsoft's Chief Environmental Officer. He is Microsoft's focal point and the intersection of science, technology, and environmental sustainability. A key component of Lucas' role at Microsoft includes leading our AI for Earth program, a significant investment in deploying Microsoft artificial intelligence technologies for environmental solutions in the areas of climate, water, agriculture, and biodiversity conservation. Besides his role as Microsoft, Lucas is an internationally recognized environmental scientist. Last year, Fortune magazine named Lucas one of its 40 under 40 in technology. Lucas, I think today is your birthday, and I think you're still under 40. But tell me if I'm wrong. Before we hear from Lisa, Bill, and Lucas, I'd like to share with you the testimony of Dona Bertarelli. Dona is a Swiss businesswoman and a co-president of the Bertarelli Foundation. The foundation was established in 1998, and it is now active in 3 key areas: marine science and conservation, life science research, and support for local communities. Dona herself is an avid sailor with deep and long affinity for the oceans. And in 2020, Dona became an advisor to UNCTAD for the blue economy. Let's listen to her.
Can you see the video now?
Yes.
The month of June is dedicated to the ocean, and as the UNCTAD Special Advisor for the Blue Economy, it is my pleasure to join this debate on how data can answer the global call to make peace with our blue planet. Because today humanity is out of balance with nature, in conflict with our fellow species, with our climate, and with our ocean. But what gives me hope is that there is a growing, passionate movement for change uniting citizens, countries, organizations, companies, CEOs, scientists, and politicians. The problems we face are complex, interconnected, and evolving, and you cannot change what you do not understand. Good data, science, and artificial intelligence can enhance analysis and understanding and leads to better decision-making, better governance, and better outcomes for our blue planet. Accurate data not only contributes to making peace with nature, it is absolutely essential. As a sailor, I've witnessed the declining health of our ocean. As a philanthropist, I know how important it is for governments, the private sector, and local communities to work together and invest in science-based decision-making and technologies that can transform ocean protection and empower people to make peace with the ocean. The challenge is as vast as the ocean itself. As we embark on the UN Decade for Ocean Science, marine resources and biodiversity continue to be plundered by overfishing, polluted by industry and agriculture, and threatened by climate change. The overall value of the ocean as an asset is higher than the UNCTAD's estimate of an annual $2.5 trillion of tradable ocean-based goods and services. With 3 billion people dependent on a healthy ocean for their food and livelihoods, we need to better understand our relationship with the ocean. If we are to achieve a sustainable and regenerative blue economy, we need to change how we value the ocean's biodiversity while still alive, how we trade, how we change our patterns of consumption and production, as well as our food and transport systems. We must work together across all sectors to advance data-driven research and make it accessible, to help close the technology gap between North and South, and to inform good policy making. The Bertarelli Foundation Marine Science Program advances understanding of the critical role of large marine protected areas. It is pushing boundaries through innovation, capacity building, and generating the best science and data, validating the importance of large MPAs for ocean life and climate resilience, both within and beyond their borders. The Pew Bertarelli Ocean Legacy Project encourages better marine spatial planning, designation, and implementation of MPAs through research and technology such as satellite and remote sensing or eDNA analysis of seawater samples. But to realize the potential of MPAs, these must be enforced, and that requires investment and innovation in data collection and analysis. So it was only logical that I should partner with Global Fishing Watch to found Marine Manager. It is a first-of-its-kind technology portal that provides interactive ocean data in near real time in an easy-to-use interface for free. It allows users to track vessels involved in fishing, tourism, oil drilling, and shipping, and overlay this with oceanographic and ecological data sets to see the impact of human pressures and climate change on their MPA and its biodiversity. The portal is being trialed in 5 sites: Palau, Ascension, Guyana, Niue, and the Galapagos, and is fully scalable. This portal puts data at the fingertips of policymakers, managers, and communities, giving them the power to make informed decisions and manage huge ocean areas more effectively. Data and science empower, unite, motivate, and accelerate change, and can drive progress towards global goals for the ocean, for climate change, and for the protection of our planet. The world needs to invest in new ways to harness technology and innovation, including artificial intelligence, to make information accessible and actionable. Fish know no borders, and neither should science or global commitments to achieve peace with nature for a sustainable future for all.
Thank you. So, Professor Levin, we have just heard Dona Bertarelli emphasize that we depend on the ocean in so many ways: livelihoods, food, transport, tourism, even the very air that we breathe. But our oceans are under threat. And you have previously mentioned that the oceans take up 93% of the excess heat in the atmosphere, which leads to oxygen loss, and that oceans absorb 26% of carbon dioxide from the atmosphere, which leads to ocean acidification. Could you please tell us about the state of knowledge about the oceans, how it has evolved, and where it may be going, please?
Sure, thank you. I would be happy to. And I'd like to do this with some imagery. Can everybody see what I'm showing now?
Yes, I can definitely.
Yes, yeah. Great. We've come a long way in our understanding of the ocean, of the deep, and I'd like to focus in particular on the deep sea. This is basically driven by an abundance of data and our ability to actually view or image the ocean and the animals that live within it. So when I am speaking of the deep sea, I refer to the area below 200 meters or about 600 feet. In fact, most of the ocean is deep, and the deep sea is the largest habitable volume on our planet. This is a truly vast area, and as a result, the data information about the deep sea is very sparse. However, the last, I would say, 50 to 70 years has seen an explosion of new technologies, new exploration tools such as sonar and different kinds of acoustic tools, floats and camera sleds and submarines and autonomous vehicles and so on. And all of this has generated massive amounts of data and revealed an unknown habitat, an unknown wealth of habitats. We originally basically viewed the deep sea as a large bowl of dark water, very desert-like, and we now know the seafloor is covered with a myriad of different ecosystems. There are low oxygen zones and abyssal plains. There are chemosynthetic ecosystems like methane seeps and hydrothermal vents. There are tens of thousands of underwater volcanoes called seamounts. There are thousands of canyons cutting our margins. And even the marine life, the sponges and corals, create their own habitat with massive reefs. Along with the discovery of these ecosystems has been the finding that each has its own biodiversity, but also that they generate resources that people are interested in. There are phosphorites of interest in low oxygen zones, now being targeted as for mining for fertilizers. There are polymetallic nodules in abyssal plains that are rich in metals, and crusts on seamounts that are rich in metals as well. The canyons, and I should say, and massive sulfides that are rich in metals at hydrothermal vents, all of these being targeted for seabed mining. There are aggregations of organic matter in canyons that turn into oil and gas that we're now starting to extract in deep water. There are aggregations of live fish around seamounts and methane seeps that we harvest commercially, and the cold water coral reefs are known to be nursery habitat for juvenile fishes. We're even looking to the mesopelagic, the deep, tiny fishes that migrate up and down as a new fishery. As we discover these habitats, we've found the animals have evolved to live in extreme conditions and basically have superpowers, to live at the very high temperatures or very high hydrogen sulfide levels or very high pressures. They can survive extremely low oxygen and extremely low pH. They have the superpower of making food from chemicals, or my favorite one is extreme longevity. Some of the fish can, like the Greenland shark, can live to 400 years. Some of the corals and sponges can literally live thousands of years. So we've come to understand this biodiversity in this vast realm to be a service, a type of ecosystem service, with new species, with genes that provide the potential to adapt to change, They're enzymes with important properties, metabolites that have biopharmaceutical potential, lots of biomaterials, and other properties, anti-fouling, detoxification, fermentation, pyrolysis, templates for artificial blood, skin products, and I could go on. But basically, and we've just begun to scratch the surface, because here I show you the records of deep ocean biodiversity from the OBIS, the Ocean Biodiversity Information System. You can see that, in fact, there are no records for the most of the ocean. And so we still have a lot of information to collect. And one of the great motivators is that our ocean is the planet's greatest climate mitigator. As you mentioned, we have massive heat and carbon dioxide uptake. And this is carried into deep water by the thermohaline circulation, the conveyor belt, with effects on animals, changing their distributions, loss of biodiversity, altering migration patterns, compressing habitats, and even dissolving the non-living parts of deep water coral reefs. And so as all of this happens, we know that climate change is going to interact with human disturbance in the deep sea, and data are needed for both of these to manage the ocean and to promote deep ocean sustainability. And really, I'd like to just close with the idea that we have the UN's Ocean Decade for Sustainable Development that has just begun. It offers an amazing opportunity to join forces in advancing our ability to acquire, manage, and benefit from ocean data. There are a number of deep ocean programs endorsed by the decade that I've listed here, the Challenger 150 and the Deep Ocean Observing Strategy, and there are others. And I think we can bring together many different ocean stakeholders in service of ocean sustainability. Thank you. Let me escape. Let's see if I can stop.
Thank you.
Here.
Thank you very much, Professor Levin. Professor Adams, turning to you, we heard Lisa talk about the Ocean Decade for Sustainable Development. There are many events taking place right now, and to achieve the vision of making peace with nature, Secretary General Guterres called on member states in 2021 to declare national climate emergencies, to submit nationally determined contributions on reducing emissions, and phase out fossil fuels. What opportunities do you think can be realized in the 3 global meetings focused on the ocean, on climate, and on biodiversity in the second half of 2021? The PGA high-level event, the Biodiversity COP15 in October in China, and the Climate COP26 in Glasgow. And how do you think this overall plan will rely on data? Professor Adams.
Thank you, Jean-Yves. That's a really interesting and a really large question. We're at a very interesting moment with, as you say, a series of international meetings taking very seriously the need for transformations in globally in the relations between human economy and society and the global environment. And Lisa's pointed out brilliantly that there's such a lot we don't know, obviously, especially about the deep ocean, but one could pick many other environments which also we're very ignorant if we presume to be managers. And also that new technologies are really transforming the amount of data, the kinds of data that we're getting. I mean, there's all sorts of new sensors, there's floods of new data, and they're addressing sort of new spaces, new environments, things that were previously off the map. So it's really exciting. I think the first thing I'd say is that the meetings need to be understood not as scientific meetings. They're essentially political. They're about governments coming together to discuss and make decisions. They're an opportunity for sort of new relations with the global environment, but they're not by any means going to be sort of analyzing the data and making decisions on the basis of it. There's a lot more going on because the choices are genuinely hard ones, as we know. I mean, the choices about switching an essentially unsustainable development path, which every country has been on with further or less far down it, shifting that into a sustainable track is really tough, and it's going to be politically very difficult. The second thing is to say that science at the same time is absolutely central to these meetings. It informs decision making. It is the chief thing that should and to an increasing extent does inform decision making. Not directly. It's not a matter of scientists reporting their best data, their best conclusions, and politicians meekly making wise decisions. That's not really how things work. But it does inform debate among decision makers, politicians and diplomats and others who are at these meetings. And it also informs popular understandings, the understanding that citizens have of the deal that they have with their government and the deal they have with nature. So I think science is really important, and the new science, the new technologies, the new data sources are really important. It's worth saying that in a sense, data is neutral. It doesn't tell you what to do. It's what it gives you information, gives different actors information on which they can act. Better data on the environment can drive the destruction of nature as well as its protection. You know, fishing industries, for example, have for generations now used better and better technologies for finding fish, and they're not necessarily managing the stocks they find sustainably. So data is neutral. What's not neutral, I think, is the way we analyze it. So algorithms are not neutral, as we know. They can be better or less good, but they do incorporate biases. And the question then is really not only what data can be achieved, but how do we analyze it? How do we translate it into the kinds of form that decision makers and citizens can make use of? So if you like, what values and whose values do we actually use to structure both the algorithmic decision making, the automated analysis of data, the presentation of synthesis of data, but also how do we then frame the decisions? Those are really big questions. So there's a data question, there's a science question, but there's also a science into policy question. It's really, really critical this year and at the present time. And I suppose the thing that I find most exciting is the possibility that that digital devices, digital data can empower publics, can empower the general public to understand better the claims humans make on the non-human world, the state of nature, the drivers of environmental degradation, and the ways in which one can engage with it. And so I think there is a really interesting question about, or possibility of getting data from and for the public, from the public as a source of information through social media and other sorts of things. And lots of people can be turned into observers of nature, and their observations can be synthesized using the power of digital technologies, but also to people. You know, people are not passive recipients. It's not going to work if people are just passive recipients of government instructions. You can see that in the debates around responses to the COVID-19 pandemic, for example. The public is intelligent, or it contains a lot of people who think hard about the situation they're in, and they need to understand the plight, if you like, of the global environment. So data from people, data for people. And I think if you can do that, you can actually empower people to ask of politicians and ask of corporate leaders for the kinds of transitions that we need. So that bubbles up from below, and I think there's a role for technology in driving that kind, in empowering that kind of thing, not forcing it, but in letting people say, I now understand what's happening, and I'd like it to happen somewhere different. Will somebody please go and negotiate and make that happen? So there's a chance here to get sort of demands for a sustainable future coming up from the bottom rather than raining down from the top from environmentalists and others. Thanks.
Super, thank you very much. Before I move to the next question and to just commenting on what you just said, Professor Adams, I would like to invite our audience to put questions on the oceans, to put questions on the state of international discussions about environment protection, on the role of digital technology. So please put questions, and after we hear from Lucas, we'll open the floor to your questions. Do not hesitate to use the chat to put those questions. They will be read out after we hear from Lucas. Dr. Joppa, we have spoken a lot about data. Data which is missing to know about the deep oceans. We heard Lisa Levin mention it. Professor Adams talking about getting data for and from people. Let's talk about technologies now, and in particular to carbon emission reductions. The Transform to the Net Zero coalition of companies, of which Microsoft is a party, and which are all companies on the path to carbon negative status in 2030, we need to remove really millions of metric tons of carbon dioxide from the atmosphere each year in order to meet those pledges. So how, in your view, can digital technologies and data sharing inform and scale the carbon removal markets?
Well, thanks for the question. And before we get into that, I just want to say thanks for having us here. And it's a bit strange to actually be on a call with both Lisa and Bill. Lisa and I have never met each other, but I've known your work for quite a while. The deep sea, I could watch those videos all day long. B, the deep sea, your work, Lisa, and that of others that study that environment really was some of the first work for me as I was coming up through my academic career that really made me realize, that in many ways we must be the most narcissistic species to have ever evolved. I think, we talk about living in this modern information age when 99.99% of the information we collect is about ourselves. And we do so at our peril, as I think, Lisa and Bill both highlighted. I think these environments, we talk about critical infrastructure in human societies. I work in the tech sector, and so oftentimes now it's common to hear about technology and technology infrastructure as critical infrastructure. What we forget is that climate and the environments that it provides to human society is the single most critical infrastructure that socioeconomic systems rest upon, and that foundation is cracking because of historical mismanagement, and that we have been mismanaging. Bill mentioned unsustainable pathways that basically every country has been on. In fact, I think the first time I met Bill was because I was a fan of his work and was in exactly the frame that he was just speaking about, how science and international policy processes come together. And I, as I'm wont to do, I think I was probably complaining in that conversation. I had a paper showing that we weren't going to meet some international targets in advance of one of these COP meetings. And I think Bill probably said something in his kind way that I should go and do something about it instead of complaining about it. So so hopefully that's what we're trying to do at Microsoft and many other, this is just our opinion here, but like many other organizations doing this as well. And so when I take that perspective of, hey, we have to do something. And well, what are we going to do? Well, that's a good question. It's driven by, or it's going to need to be driven by, a better understanding of where we are and a better ability to be able to track progress against any particular goals that we set ourselves. That, of course, is going to rely on data. To Bill's point, the world is more complicated than, the best available data driving, the best available decision. But that's kind of how we get there. And we don't have great data. Can you hear me, Jean-Yves?
Yes, absolutely.
Getting a bad network quality.
Yes, I can hear you.
You can? Okay, sorry. It looks like I was getting some network quality issues. So for us at Microsoft, it's really about how do we build the data systems that allow human societies and the governments that manage them to make the best, most informed decision, incorporating, of course, all the socioeconomic needs that governments take into account, but also the true state and status of the planet, and particularly from a carbon perspective, the emissions. And so at Microsoft, we think about how we help transform the world to a net zero carbon economy by 2050. That's an extremely easy thing to say. It's obviously significantly more complicated to achieve. It's actually a really easy equation to write as well, right? It's just emissions minus removal must equal 0. Now, the emissions side of things, how do you actually measure emissions at the global scale? Well, that's fairly easy. We have organizations like Scripps, for instance, that have been measuring atmospheric CO2 for a long time. So at a global scale, the measurement of emissions is pretty good. The system breaks down rapidly after that because we know how much carbon's in the atmosphere. Where it came from, how it got there, that's actually a little bit more difficult. I represent an organization that cares about understanding its own emissions. And I can tell you that it's difficult for us at Microsoft to figure out where all of our emissions are coming from. Not so complicated when you're asking us about what people call Scope 1 emissions, which are the emissions we directly emit through our fleet vehicles or things like that. Much more complicated when you get into things like Scope 3, our supply chain and our value chain, 1, 2, 3, 4 degree separation relationships that we're trying to, measure and account for emissions and ultimately drive reductions of. So we have problems there that digital technologies can help, bringing an enterprise-wide system so that we can bring all that information together. You asked, however, about carbon removal. And carbon removal is the second part of the net zero equation. It's, something that humans are trying to figure out how to engineer efficiently and effectively through technologies like direct air capture, literally sucking air through giant fans and separating out the CO2 from it and being able to sequester that in geological rock formations that will contain this carbon for tens of thousands of years. But it's also something that evolution, through biological process, has been innovating on for millions and millions of years, right? I mean, that is what trees do, and plants in general, and other organisms as well. And so we have these two opportunities for removing carbon from the atmosphere. We can harness nature well, first and foremost, we can stopping nature from doing its job, right? So reducing deforestation, reducing ocean pollution, stopping nature from doing its job, first and foremost. Second, we can harness nature to do carbon removal on our behalf, afforestation, reforestation, soil carbon sequestration through more effective and environmentally friendly agrarian practices or agriculture practices. And then the third option is we can try to emulate nature through engineered systems that do what nature has shown us is possible, which is to remove CO2 efficiently and effectively. Those things we can all do. Technology can help us get there, particularly in the nature-based solutions space, because while we know how, for instance, trees remove carbon from the atmosphere, the science is pretty good there, right? What we struggle with is the measurement, verification, and validation of any particular carbon removal project that harnesses nature-based solutions. And that lack of verification, that lack of validation is ultimately what slows the growth of the markets that the world is going to need to be able to actually get corporations like Microsoft and governments like the United States, et cetera, to set up systems whereby people are investing in carbon removal. And so there's a ton of opportunities, whether that's through satellite and other form of aerial remote sensing systems to actually assess at large scale the state of natural systems, so we can apply proxies, basically how much carbon we think is there, because oftentimes we can't let kind of the accuracy and precision problems be the enemy of the good. We know enough, if we can get an assessment of these systems, about roughly how much carbon is there. But then we can also move beyond from proxy or from estimates to actuals, and we can start using things like soil probe sensors to be able to actually directly measure how much carbon is being sequestered into agricultural plots of land. And when we do that, once we have that data foundation, then the kind of economic innovation, the societal and markets and all government regulations, all of that then can innovate on top of it. Mm-hmm. But when there isn't a source of data truth, that innovation has the potential to get a bit wonky. And I worry that while I don't worry that my term wonky is not maybe academic enough for this conversation, I do worry that that if we let things get wonky enough, we're going to find ourselves on a pretty dead-end path. And time is going to have run out. Because remember, we talk about a net zero carbon economy by 2050. If we start today, which Microsoft has, if the world starts today, the technology and socioeconomic innovation and socioeconomic transformation that's going to have to happen in the next 30 years is going to put to shame anything that humans have achieved to date. It's going to make the industrial revolution look like child's play. It's going to make the fourth industrial revolution look like child's play. It's the fourth industrial revolution on steroids. And so to make sure that rapid pace of evolution can happen on a really tight time frame is going to require some very tight definitional boundaries and a data layer that provides a horizontal sense of truth to the markets so that everybody can act on top of it. And there you go.
Thank you very much, Lucas. Really, what all of you have said, in fact, is really fascinating. Hear you passionate about your topics and what you just said, Lucas, about the need for data truth. I think that's the term that you use. Of course, resonates a lot with all of us here on this call. I see that we have a number of participants, and I would like to give them an opportunity to put questions to you. I'm sure that you would have a lot to discuss together and with each other, but I would like to give our audience, I'm sure, I can see you, Lisa, saying yes, yes. I would like to give our audience an opportunity to put questions and for you to answer. Daniel, do you have questions from the audience?
Yes, I do, Jean-Yves, and indeed, those comments from our panelists have triggered a flurry of questions. So let me start right at the top with Carolina, and she is asking a sort of three-part question. I'll begin with the first. I wonder your take on the G7 data initiative recently announced. What do you expect from that? And also the potential successes of efforts such as the data development partnerships. So this is from Carolina, who wants to know really about the G7 data initiative and the data development partnerships.
Who is taking that one? G7, I suppose, is the one that ended Calais Bay 2 weeks ago, or 10 days ago.
I'm not by no means expert on G7 or the discussions, apart from which person ate fish and chips at which pub, which seemed to obsess the media that I saw. But I think these are good initiatives. I mean, I think the COVID-19 pandemic has done quite a lot to, well, it's done two things really. I think one is that it's raised the prestige of science. I mean, internationally, in every country, we've looked to scientists, and they've come through with very rapid innovations of vaccines and so on. So I think, in a sense, to put it generally, science's flag is flying very, very well in the breeze right at the moment. And I think the second thing it's done is demonstrate the importance of international collaboration, which I think is really significant, because I think we're no longer in the period at the end of the 20th century when it looked as if international communication was going to be very easy. We're at a time of where international relations are tougher, more contested, more awkward, and that's not just in the UK because of Brexit, but lots of other things, lots of other kinds of barriers going up. So I think these initiatives, which I don't know much about in detail, it seems to me they're quite exciting. The notion of sort of exchange of data, the notion that in a sense science ought to be open access internationally rather than being privately, corporately owned, and how you deal with that balance, and how you use the fantastic power of corporations to do amazing things very fast, how you deal with that in the context of your desire to get the best social benefit, and how you make that social benefit international. You don't just let it stick in the wealthy economies, but you do it. And we haven't got that right by any means with the pandemic, of course, but I think it was good that the G7 leaders talked about it, and I think they used the right sorts of words and the right sorts of frame, but seems to me much more to do.
Thank you. Any other reaction on this important topic of international cooperation at the level of G7 or beyond? Yes, Lisa?
Just a quick comment. I know that I'm not that familiar with the final G7 outcomes, but I do know that they've committed to building the ocean into all of their actions. So that's a very important thing. And then I want to comment on partnerships. Since about half the planet, well, 60% of the ocean, let's say, is in international waters, okay? The partnerships that have to be built there involve bringing the different UN agencies that have, that are very siloed. And I saw there was a question about silos in the chat, some manage fish and some manage minerals, and there's a new treaty for biodiversity under negotiation, and bringing all of that together in a way, and then getting business and industry and science and governments to all engage together, and managing that part of that vast part of the ocean is really important going forward. Thank you.
Thank you. Lucas, any views on the state of international cooperation?
Well, I mean, probably no views that won't get me in trouble. No, I mean, I think I think there's a good question actually down here from Ricardo. So sorry for skipping ahead on the moderator's job here, but about the question is to me or Bill, do you envision legal frameworks, trade, investment agreements, integrate data, AI for guidance and enforcement? How do you accelerate this to happen? We spend a lot of time thinking, watching, and then advocating for regulatory progress on climate more generally. I think here in the U.S., we just saw our SEC, Securities and Exchange Commission, call for comments. Microsoft just had a long submission with our input about the way that climate disclosure should happen as a regulated aspect of corporate proceedings. But when I think about, so I do think that there's kind of two ways that I see this happening, and I'm no policy expert, so when history happens, when the future happens, I'll read history and see if I was right. But there's basically the investment landscape, and we're seeing actions like the SEC's interest in getting standardized ways for people who are looking to put capital to work to be able to have access to environmental information and climate relevant information. That's one way you drive innovation, at least in a modern capitalist system. The second is if you look at some proposals like in the EU and CBAM, the cross-border or the carbon border adjustment mechanism, something like that, or something like a carbon price, but something that happens at the trade barrier level, that's really when one of those things passes in a major economy, that's the domino that's really going to start to push the global economic transformation, because it's going to beg the question, well, how in the world do you actually know the emissions embedded in any good or service being imported or exported across national boundaries? Well, that's that data layer, right? That's going to be this, basically this immutable layer of data truth that's going to have to pass back and forth, because literally legal structures are built on top of it. And then we're going to be able to start putting in pricing, and then we're going to be able to start putting in, however governments want to enact policy regulations. And so I ultimately think, I love what the UN is doing. I think the frame, the scientific consensus bodies like the IPCC, IPBES, those are incredibly important institutions. Then the frameworks like the Paris Agreement and the COPs are all, that's the high level important work. But where this stuff in my mind is ultimately going to be governed is through those regulatory actions that ensure that one country keeps its own house in order while also having leverage over its global economic influence, or leveraging its global economic influence. And I don't think call me crazy, but I don't think we're that far away from something like that really starting to push, as I said, those dominoes down the line.
Yeah. Thank you very much. Thank you for your comments. Really very interesting view on this. Daniel, I think we have time for at least one other question. So
sure, I'll prioritize an external guest, Derek. Derek is asking, can the increasing access to natural capital digital data streams lead to truly novel business models? So really around whether the access to digital data streams can give us more insight for better business models, and also financial instruments, can they shift our behavior towards regenerative dynamics? And if there are any examples. So that's a question from Derek.
Access to data as giving us insights for new business models. Who has some views on that one?
Well, go for it, Bill.
You can follow me, Lucas. This is really interesting, and it's not something that I know a great deal about. The first thing I'd say is that I think there is more appetite for data on natural capital than there is complete science to back it. This is a field which has expanded so fast and got into policy so fast, and then got into the minds of politicians so fast, that the science is still lagging behind. We don't know enough about how ecosystems work. The kind of work that I think maybe Lucas was involved in, the Mattingly model that Microsoft had a role in, trying to understand how ecosystems function. That basic research is still going on, and immensely complicated. It's nothing like as simple as the atmosphere to model. Ecosystems they're scaled, they're immensely complex. And the number of variables is massive. You have to model out everything from the genome up to the biosphere, and that's very complicated. So I think there's a lot of science which needs to be done, and so asking for hard data that's really accurate on natural capital, so that you can wrap it into payment schemes or business models, that's a bit of a premature ask, although we are asking it. And scientists are doing their best to come up with patches, but it's botched as yet. Not botched. Botched sounds a mistake. It's cobbled together. It's a car put together in the back of a garage by a bunch of enthusiasts. It's not not the product of a big factory. But that's the first thing I say. The second is, I think measurement doesn't need monetization. And you don't need to monetize to make decisions, but you do need to measure. And there's a lot of things we don't understand. We don't even know exactly what to measure. We don't know what's there, as Lisa was saying, but we also don't quite know what attributes are really significant. You know, what does it, in what way does it change the function of a forest if you lose a particular species out of it? It's very hard to say. We just don't know that. So I think there are things you can do, like ecosystem services, like all the businesses around environmental cleanup and environmental restoration. There's lots of business opportunities in this. Some of them will turn out to be really, really good for the global environment. Some will turn out to be, you know, more or less a waste of time in terms of reaching sustainability, although they could be perfectly good businesses like anything else. But it is complicated, and I think that the science need, particularly in the area of ecology, is massive still. But Lucas, this is your field, not mine, so perhaps you've got a better comment.
Well, I would just reiterate everything you said. I think that there are places that we can start. Carbon is a great one. I think one of the things that differentiates our climate crisis, if I can simplify it, from our broader environmental crisis is that our climate crisis has known units and our environmental crisis doesn't. And once you have known units, then you can measure. And once you can measure, you can create markets. And so we have incredible amounts of novel business models that we see all over the place. One of my favorite examples was a small startup we started supporting just philanthropically years ago. And we've been so pleased to see them kind of become a larger kind of folks investing in them. Their company's growing, an organization called Sylvia Terra. They use remote sensing and satellite imagery to literally count individual trees. And obviously there's a market for that in the timber industry. But once you can do that, there's also a way to bring people who have been previously excluded from a different market, the carbon offsets market, for instance, where people pay other people not to cut down trees or deforest, for instance. Well, if you're a small landowner, 10, 20, 30 acres, you just don't bring the economies of scale for that market to ever allow you to bring your land into play. But the vast majority of land on Earth is owned by small landowners. When you look at it from an ownership perspective. So the ability then to take data and machine learning systems and say, hey, now I can just scale. There's no cost to my scale once I've done this. So now, if Bill or Lisa are individual landowners, if you have 5 acres, I can include you in a market that you were previously excluded from, and somebody from somewhere else could pay you for some service. So there's lots of business models there that once you have a unit that you can drive measurement around, then the markets start to be able to be formed. When we talk about things like ecosystem services, of course, as Bill said, this is my area, but I'm kind of the most quick to throw it under the bus of trying to price it, because the science is still so immature. We don't even have a unit. Of people talk about ecosystem services. I'm like, what's the unit? And no one can tell me. So I'm like, well, sweet. Then I don't know what you want me to do about that. I write lots of papers about it, right? And I'm embarrassed that I don't have units in them because scientists should have units. But we know that they are important. We know that they provide the foundation for our modern day economies. But I do think, to Bill's point, not everything needs to have a price on it for us to manage it, and we don't actually have to have units, right? I came up from, I studied in the department that Aldo Leopold founded in the United States, a famous conservationist, and he has a quote, the key to intelligent tinkering is to keep every cog and wheel. Well, the key to intelligent tinkering from the ecosystem services space is to focus, in my opinion, to focus on the climate, something that we have units that we can manipulate, make sure that we do achieve net zero, rapidly changing climates due to human-caused influence is one of the most existential threats to ecosystem services. So let's focus on the things that we can do. Let's not let, fallacies of overburdened accuracy and precision measures stop us from understanding that we still can manage these systems, even if we don't have units, even if we can't fundamentally measure the performance of them. So I know we're at the end, and I'll be quiet.
Yes, but Lisa, you wanted to say something?
Sure. Can I just pop in?
Sure.
I like your point about climate. I mean, climate is everything really now. The links to food, to water, to security, to every aspect of carbon. I mean, but it's all completely interlinked, just coming off the IPBES meetings, they're talking about their nexus and transformative change reports. And this is the point, that climate isn't separate anymore from anything. But in terms of, I don't know too much about business models, but there's so many ways that industry in the ocean need digital data. I mean, the aquaculture industry, for example, if it can see the acidification events or hypoxia events coming, they have so many ways to protect their product instead of having mass die-off. If the shipping industry could actually hear the whales in the vicinity, or have a way to avoid these massive ship strikes through technology, and we tag the mammals, but we can passively listen to the mammals, other scientists, and there's so many different ways to bring real-time digital data into business management. I think we should get more creative about it too. I know we're running out of time here.
No, but thank you very much. I was very happy to hear you also on that question. Each time we do these digital fast track studios, we say, well, it's too short. We do this for 1 hour, and we come to the end, and boom, we don't have time to draw big lessons from the discussion that has taken place. I would like to thank you, the three of you, for making these discussions so lively, sharing your views on the importance of data, lack of data, missing data, or the importance of data that we have, and looking to the future and the role which data and digital economies will play in order to help us protect our environment. So thank you very much. In the name of all the audience, if I may speak in their name, for me it was really a fascinating discussions, really fascinating to hear you. I hope that our audience is also just as fascinated as I've been, and they will follow you, each of you, in your publications and other manifestation that you can give them of your knowledge and your passion for the protection of deep oceans or the protection of environment generally. So thank you again very much. Yeah, we'll move to our next digital fast track studio. We'll see what's next on the agenda. That's probably for after the summer. In the meantime, many thanks to all of you.
Thank you.
You.
Bye.
I know.
Thank you.